velocity time graph for uniformly accelerated motion. The changes in the velocity of a car in specific time intervals are given in the table. Also, as per the table, the velocity time graph is shown here. The nature of the graph shows that velocity changes by equal amounts in equal intervals of time. Thus, this is uniformly accelerated motion. Now, can you tell how much does the velocity change every 5 seconds? From the table, if we calculate the difference between two consecutive velocities, we see that for every 5 seconds, there is a change in velocity of 8 meters per second. This difference in velocity can also be shown with the help of the graph. For this, let us take two consecutive time intervals, like 5 and 10. From these points on x-axis, draw perpendiculars to the graph line. From the points where these perpendiculars meet the graph line, draw two perpendiculars on y-axis. These perpendiculars meet the y-axis at 8 and 16. The difference between these two perpendiculars is the difference in the velocities in 5 seconds. This difference is 8 meters per second. The graph shows that for all uniformly accelerated motions, the velocity time graph is a straight line, while for non-uniformly accelerated motions, the velocity time graph may have any shape depending on how the acceleration changes with time. Now let us understand how to determine the distance covered in the given time interval. From the graph, we can determine the distance covered by the car between the 10 seconds to 20 seconds, as we did in the case of the train in the previous example. But here, the velocity of the car is not constant, but is continuously changing because of uniform acceleration. In such a case, we can use the average velocity of the car in the given time interval to determine the distance covered in that interval. From the graph, it is seen that the average velocity of the car is 32 plus 16 divided by 2 equals to 24 meters per second. Multiplying this by the time interval, that is 10 seconds, gives us the distance covered by the car. The distance covered equals to 24 meters per second into 10 seconds equals to 240 meters. Equation 1. Come, let us check that whether the distance covered by the car is equal to the area of the quadrangle ABCD or not. The area of ABCD equals to the area of the square AECD plus the area of the triangle ABE. This equals to AD into DC plus 1 upon 2 AE into BE. This equals to 16 meters per second into 10 seconds plus 1 upon 2 into 10 seconds into 16 meters per second equals to 160 meters plus 80 meters equals to 240 meters. Equation 2. From this, it is clear that the area of the quadrangle ABCD is the distance covered by the car in the time interval from 10 seconds to 20 seconds. From 1 and 2, we understand that the distance calculated from the average velocity from 10 seconds to 20 seconds is equal to the area of the quadrangle ABCD.